Hello everyone, welcome to the YouTube channel Usha Physics Online Class. And guys, today in this video we are going to discuss something very important for our upcoming CSI Net Physics exam. So guys, this video is going to be in the series that is Target 20, which is a series in which I am mainly going to provide you the videos for your upcoming CSI Net Physics exam and also an interview which is December 2020. So guys, now I am going to talk about the discussion we are going to do in this video. So that is the discussion about the quantum mechanics, most important topic which every student need to prepare. Now what are this topic and how this topic will help us to score good marks. So guys, whenever we start the preparation to our any exam, so the every important thing in the initial stage is going to be know about the most important topic, okay, which can help us most of the topic to solve most of the questions in this exam. That's why I'm going to make this video. I'm going to provide you the video idea about those topic which are going to be very important done, and mainly from quantum mechanics we are going to discuss this topic in this video. Let us go to the video now. The first point about quantum mechanics is that all of you have heard that quantum mechanics applies in the microscopic domain. It applies to electrons, atoms, and things of atomic sizes. This is the only partly true. It applies to everything. It applies to human beings, galaxies, the universities, presumably, and it applies the electronics, photons, and so on. It's just that the manifestations of quantum mechanics become very dramatic when you look at extremely small objects. They become more dramatic when you look at extremely small objects moving very fast relativistically. So that's the reason why one feels that quantum mechanics is applicable only in the microscopic domain. Not true, it's applied everywhere. Basically, quantum mechanics is a turnout of the classical mechanics, but classical mechanics tell us how everyday objects move. It is the theory of motion. It was explained by Sir Isaac Newton. It was what is the classical mechanics definition, and in the olden days, classical mechanics was the only kind of mechanics. Now, for centuries, Sir Isaac Newton was explained as like three laws. That was the law of inertia and Newton's second law, Newton's third law. Newton's first law, it was an object in motion tends to stay in motion, and Newton's second law is force equals mass time acceleration. And then third law is for every action there is an equal and opposite reaction. It is all very well known about this law. But in the 1920, classical mechanics was replaced by quantum mechanics. For example, in 1687, Newton's mathematical law is available, and 1788 it was Lagrange's mechanics was developed, and 1834 Hamiltonian mechanics was developed, and 1864 Maxwell equations was authors was prepared, and 1900 Boltzmann's entropy equations was released. But in the 1920s, classical mechanics was replaced by quantum mechanics. The word quantum mechanics means the smallest possible amount of something. I can repeat. The word quantum means the smallest possible amount of something. Quantum mechanics is a new acknowledged as the correct understanding of all kinds of motion. So far, no one has ever found any predictions of quantum mechanics to be wrong. Quantum mechanics applies equally well to small things and big things, but it would be foolish to use quantum mechanics, where classical mechanics would enough. A mechanic does not need quantum mechanics. The electrician does not need quantum mechanics. Quantum mechanics does not need for designing a spacecraft. But in plasma physics, it needs quantum mechanics. And we can explain need for quantum mechanics. Quantum mechanics is absolutely essential for understanding atoms and their properties. And nanotechnology is 100% based on quantum mechanics and nuclear physics. In nuclear physics, there was an electrons was in collisions, electrons was in non-collisions. It was determined by using the quantum mechanics, and radiation therapy is what it is also need for quantum mechanics. But how quantum mechanics began? By early 1900s, physics had already made great discoveries that are conservation of matter and energy, wave nature of light, electromagnetic radiation, electromagnetic induction, nature of heat as a random motions, prediction and discovery of electromagnetic waves, discovery of electrons and atoms, and X-rays. Classically, we can determine both the these are the great discoveries. Classically, we can determine the position and the velocity of this body. Not true in quantum mechanics. Just like we can explain Heisenberg uncertainty principles, that is delta x and delta p greater than or equals to x dot by t. Whenever the position was increased, by automatically momentum of the particle it was decreased. Whenever the position was decreased, the momentum of the particle it was increased. Attempting to determine its position changes its velocity. In general, any observation of small things disturbs it. I repeat again, attempting to determine its position changes its velocity. In general, any observation of small things disturb it. Thanks for watching. Subscribe for learning and share for helping. Bye.